So let's begin. Review from Friday where we left off. Get settled. So y is x squared plus 3 root x, not a polynomial. Okay, so many of you are looking right here. Right? So that's good. Now, why does this eliminate as being a polynomial? What about this? Okay, so yeah, there's two criteria. You're always looking at the exponents, and n has to be positive. No, actually, n has to be a natural number. It has to be a natural, which is 1, 2, 3, 4, and so on. Can't be negative. But also, what else was there? That was good. Has to be a natural. 1, 2, 3, 4. Could not be a fraction. Not be a fraction, right? So that's the problem here, is that you can rewrite this as x to the 1/2. The fact that that's the half power, it's not a natural number, 1, 2, 3, 4, and that's what makes it not a polynomial. Because square root of x equals x to the 1. And that is no good. We also couldn't have fractions, or we couldn't have negative numbers. Okay, so no negative exponents was the another one. And that is pretty obvious if they said, x to the -2. Okay, that's easy. But if in the problem they had 1 over x squared, you had to recognize that, well, that's the same as x to the -2. So whether they put x to the -2 or 1 over x squared is the same thing, and therefore would not be a polynomial. And this is very similar to function, not a function. Why do we want to know if it's a polynomial or not? Same reason we want to know why it was a function or not. There's many things we can do if it is a function, and there's many things we can't do if it's not a function. And we'll find out here in the next few months. Many things we can do if we have a polynomial, and then things that are impossible if it's not a polynomial. So you want to be able to distinguish the two from each other before we start just doing a bunch of problems without knowing why or why not we're about to do them. All right, so that's what we're leading off. Everything's polynomials. We're working towards how do we solve the factor problems. Everything for the next few months is going to be, well, we've done this. We've solved x squared plus anything. We've done clean the square, we've done factoring, we've done the box method, we've done a lot of stuff up to x squared, right? Okay, so what's next? What happens when it's x to the third, x to the fourth? What happens when we do anything above x squared? This is where the algebra part 2 really starts. Okay, up to this point, this has been all algebra 1, even the last test. With the exception of I, square root of -1, that was new. But exception of that, everything we've done was just review from algebra 1. So we're really starting to transition into, well, what happens when we have more than just a quadratic? It's something like a cubic or a quadruplet. Now, believe it or not, none of this x or box stuff works with x to the third. If we're trying to factor x to the third and x to the fourth, a lot of the box stuff doesn't work. And we have to do something you might have remembered, maybe not, but it's good old-fashioned home division is what we're going to use. So let's practice some long division with some regular old numbers, and then what we're going to do is we're going to take the steps, the algorithm, the process, and apply this to polynomials. So instead of having 3,756 in here, we'll have x squared plus 6x plus 5. Instead of having 72, we'll have like x minus 2. But we'll do the exact same steps as we're about to do right here. So let's just recall how we did this in the 4th and 5th grade, so we can not catch us off guard when we start doing polynomials. So the first step was, well, basically what we're finding out is 72 times what equals 3,756. That's what this means. So 72 goes into here how many times? That will tell us, well, this times this will equal this number. And it works the same thing with polynomials. So, of course, you guys have calculators, so this problem in itself isn't too difficult. But let's try it anyway. So 72 does not go into 3. 72 does not go into 37 evenly without going over. And 72, how many times does that go into 375 without going over? 5, okay, that's where we started. Good. So 5, then we did this. 5 times 72, and we write that number down here. What was that? 156? No, I can't do that. 5 times 72? 360, yeah. Then we can end in 6. End in 0. And then subtract, right? We did subtraction. 75 minus 60 is 50. Okay, here's where the 156. And then we brought down the 6. And we repeat it. And it'll be the same thing for polynomials. We'll repeat the whole process. So if we know how to do the process one time, we should be able to do it 3 or 4 times. Now, where do the mistakes usually come from if they happen at all? It's going to be on the little details. It's going to be on the little things. So 2 goes into 156 without going over. Multiply 2 times 72 and you get 144. Subtract it and you get 12. So we have a remainder of 12. Okay. So we have a remainder that's the same as 12 over our divisor, 72. Anytime you have a remainder, right here, it just becomes a fraction in your answer. We have, and then 72, that came from here. And on this problem, you would actually go ahead and reduce it and get a more simplified answer. So 12 over 72 reduces to 1/6. So your correct answer probably would be 52 and 1/6. Not too bad. Remember about this remainder part. And then on the polynomials, nothing actually reduces. We don't have to worry about reducing. Okay. So that's one little part of the bigger picture. So we're going to be able to divide. I mean, yesterday on Friday it was add, subtract, multiply. Like on the problem which is on the board, all multiply. We want to be able to divide by that. Now, before we actually get into the long division part, we're going to talk about this smaller but easier part. And that is when you're just dividing by a monomial. No adding, subtracting. It's not 3x plus y. It's not x minus 2. But it's just something on the bottom that's being added, being multiplied. So there's really 2 types of problems. There's this type where there's just a monomial on the bottom, one single term. And then there's this type where we're going to be dividing by x minus 3, a binomial. This is where we use the long division. So just like everything last week, yes, you have to know how to do it, but you have to know when to use it. You can't just use it all the time on every problem. You want to use when to use it and when not to use it. Okay, so this is when we use the long division. So first is basic distributor property. A much more basic problem that you've done for a long time would be this. Solve this for y. Solve this for slope-intercept form. Right? And what did you do? Divide both sides by 2, right? And then you got y equals 3 over 2x plus 2, right? So you divided 3x by 2, and you divided 4 by 2. You distributed the 2 to both of them. That's exactly what this is. This is distributive property. It's just that there's 3 terms, or 4 terms, or 5 terms on top, and there's a bunch of variables as well. But the property you're using is identical. You just divide each of these by whatever's on the bottom, if the bottom is a monomial. Okay? So here's what we're going to do. We're going to rewrite it. This is where the patience thing comes in. Where you say, do I really have to write it all down all again? Say yes. We're going to spend 10 seconds and we're going to write it down all over again. If this is so easy, that you think you can skip the steps, that probably means there's a lot of mistakes that could happen. Don't want to make any mistakes. And this is the easier of the problems, so let's not put ourselves in a position where we're going to miss the easy problem because we don't want to write down all the work. Notice how I write everything down. The numbers are right over the numbers. Each variable matches that's right above it or below it. It makes it much easier to follow all your work. So now I just have to do one thing at a time. 9 over 3 is 3. X squared over x. Y to the third over y squared. No problem. 15 over 3. 5. X over x. 1. Y squared over y squared. 1. 5 times 1 times 1, which is 5. We don't like the 1. Next. 12 divided by 3 is 4. And x over x, 1. Y to the third over y squared, 1. And this is one of those things where you say, oh yeah, that's really easy. Only if you write down this part will you get the right answer pretty much every single time. As soon as you're up here and you say, I'll just divide here, divide here, divide here, divide here, I'll just try to do, let's see here, 3, 6, 9 divisions just by looking at it. That's where the problem starts. Yes, it's simple if you write it down. And remember, this is going to be a multiple choice on Friday. The wrong answers will be very common wrong answers. And you might look at it and say, oh, that's super easy. Answer's A. And really it was C. Okay, so write them out. The very same, the very similar question can be written like this. Now, what's different about this, obviously? Yeah, we have this. Now, but what does that mean?
It gets moved to the bottom.
Yeah, it moves to the bottom, just like we talked about last week. So really all this means is divided by 4, C, D, F, all raised to the positive 1, which anything to the 1 power just stays the same. So in this case, it just means divided by 4 C, D, F. And now it looks just like 1A up here, where we have to distribute 3 times. Not too bad. So don't let this fool you. Do take note how this -1 only applied to this set of parentheses, the one that's attached to it. Doesn't mean we moved anything over here at all. So here you have it. Once again, let's write it out. Each of these is divided by 4, C, D, and F. And notice how I'm writing these, I'm kind of spacing them out just so I have the variables right beneath each other, right on top of each other. I'm trying to avoid any possible small mistake that there is. On here you might want to take note how there is no D on top. And then we have 4, C, D, F. One by one, little by little. Okay, let's start. 20 divided by 4. C to the 4th over C. That 1 cancels out. And then D to the squared over D. And then F over F. 1. So we don't write anything. Good. Next, -16 over 4. C over C, 1, nothing over D, so we have a D, but where does the D belong? On the bottom, so we're going to have to make a little fraction, make sure that D stays on the bottom. And then F over F is 1. This would be one of those common mistakes right here. Oh, there's nothing canceled with D. Okay, it's 4D. Nope. It's on the bottom, stays there. Continue on. 4 over 4. 1. C over C. D over D. And F over F. So So 1 times 1 times 1 times 1. Oh. You have to put plus 1? And that'd be like over here, this is a 2. So you had to put 3 over 2x plus 1, or can we just leave it as 3 over 2x? But yeah, we gotta put it same like that. In general, you want to have the higher exponents first, and so on. It's not too picky though. Just follow the back of the books lead. It'll kind of guide you on how to write the answers. These will be the multiple choice, so even if you write your answers in a little different order on some of these problems, you'll be able to match it up with some answer. Okay, let's have you guys practice. Really, let's just practice one like this. I think the first one we can all do, but let's practice one like this. So why don't you go ahead and do 2b. Notice how this is to the second power. So to start off, we will have 3xy on the bottom raised to the second power. Right. So to simplify this first, simplify that first, then go ahead and distribute on the bottom. Again, that goes away because we moved it. What does this equal on the bottom? Yeah, good. 9x what?
Squared.
Y squared. Okay, so everything gets squared. 3 squared, x squared, and y squared. That's what the parentheses mean. Square everything on the inside. Alright, so let's divide each of those. Rewrite these two parts. This divided by this, and then 27 parts. Alright, check with somebody, see what you get. See if you get the exact same answer. Don't be satisfied because I got something close that's almost the right answer, but check, make sure. So, definitely write it out. Alright? All over. 9x squared, y squared, and 9x squared, y squared. This is a positive. So here we go. 18 divided by 9 is 2. X squared over x squared. 1. Cancels out. Y over y squared. Over y. Not 2y. Over y. Good. And then we have 3x, 1, and then the z. There you go. So 2 over y plus 3xz. That's the answer. Is this a polynomial or not?
No.
No, because not because of fraction. Because of a this is a negative exponent because it's on the bottom. But if this is like just 2 over 3, it'd be fine. So it can have a fraction, except that the variable is down there, what disqualifies it. Good. All right, so those are more basic. Again, you only do the sugar property when you have like a monomial, very similar to when we were doing slope-intercept form. We just divide everything on the top by whatever's on the bottom. So the one that we first started off with is a review of long division. So let's take a look at that. You want to note that, what is 52 times 72? What's 52 times 72? Quick.
3,700.
Yes, these two numbers multiply to here, 3,756. That's what we're trying to figure out. We say, well, 72 is a factor of this number. What's the other factor? Okay, that's 52. 52 times 72 is 3,756. So we'll be doing the same thing here. Same thing here. We're trying to find out really, we're doing this long division. It's going to be x minus 3 times what? Equals x squared plus 7x minus 30. That's what we're doing here. Trying to figure out what do I need to multiply x minus 3 by in order to get it. Or, to figure this out, divide both sides by x minus 3, and you have our problem. Note that we really don't use division signs anymore. Everything's written as a fraction for division, so probably where you first want to start is here is division sign, convert to division bar, or division bar. And what does this mean? So watch me do this, just so it makes sense. It's one of those things that it's probably easier if you see the whole thing through before you try it on your own. You're so busy looking up, looking down to write everything down, you might miss it. So, like on the last problem, details are crucial. Details are crucial. Although, you know the algorithm already. It's the same thing that it is for regular numbers. So here we go. One thing to remember is you really only pay attention to this lead term, this first term. The minus 3 kind of goes along to the right, but all our decisions about what goes up top is based upon what this is. Okay, so that's what I'm doing. We first set it up, but just focus on the first term. Talking about this lead term. Okay. So here we go. X goes into x squared how many times? Okay. In other words, another way of saying the exact same thing is what times x is x squared? X. Notice how we wrote it right above the other x. Okay. X times x is x squared. So we always talk about our lead term. This times what equals whatever's inside. So these will always line up exactly. Okay. So x times x is x squared. Now we're going to do a little distributive property. X times negative 3 is negative 3x. So it's like, how did I get this? Imagine I just did this. I'm multiplying x times x, doing this, and x times negative 3. And then this, and that's what's right here. Okay. But we really don't write out that step though. It doesn't need to be shown on the work. That's where it's coming from. Now, what's the next step after this? If it is regular numbers. Subtract. Now, we really need to subtract both. We need to subtract this, and we need to subtract this. So what happens is that the signs on both of these will always change, be the opposite, because we're subtracting. Okay, so what's happening right here? Again, this is what sometimes makes it difficult. That we just said we had x squared minus 3x. We need to subtract both of those. So we're going to get minus x squared, and then we're going to get positive 3x. So that's why the signs will always change. It'll always be the opposite, no matter what. Always be the opposite. A couple implicit steps that we don't really show the work. We just have to know. All right, now we can finish this one part. Here we go. Add them up. So we get 0, which is good. Always want 0 from this first part. And 7x plus 3x is 10x. Bring down the next number, just like we did before. We always bring down the next number and repeat. Just do the whole process one more time. Whole process one more time. Question?
Will you put a negative sign before the x on the top if we're going to change to negative?
No. Changing a negative has to do with that we're subtracting here on the bottom. It's kind of like back here. Now, should we just put a negative up there on top? Just because we need to subtract down here on the bottom? No, we're just subtracting. Before we just had 360, but we changed it to minus 360 every time. We always subtract it. It's the same thing we're doing now. We're just subtracting. It's just that we have negative numbers. And up here, when we were doing this a long time ago, we didn't have negative numbers, but now we do. So if we add subtraction, saying we have to subtract, but we already have subtraction here, it's kind of like subtracting a negative. That's why we got a positive. Okay, so if we understand that much and how to do all that, it's nice because it's just the same thing all over. So we have x, the lead coefficient, the lead number, x times what equals this? 10. And it's going to be a positive 10, right? Okay. So we have 10, and this is a Schroeder property, right? 10 times x, then x. 10 times negative 3, negative 30. Change both signs. Negative, positive, add them up. What do you have? 0 and 0. So what do we find out? X minus 3 times x plus 10 is what equals x squared plus 7x minus 30. That's what we found out. X minus 3 times x plus 10 equals this. Now, really important here. This we could have done anyway. This is a quadratic. I mean, we could have gone through here and said, oh, what two numbers multiply to negative 30 and add 7? Yeah, 10 and negative 3, right? That's the same two numbers. So with a quadratic, not quite as useful because, yeah, we already have a faster way of really doing all this work. But remember, we're getting away from this, x squared. We're going to go to x to the third and x to the fourth, where this stuff in the box method, none of that works. But yeah, for a quadratic equation here, yeah, it's really just another way of looking at the same problem. But let's practice on these where we can check really easily before we start going on to the newer stuff. All right, so you guys try this one. Let's go ahead and set it up. We have x minus 1 Oh, one more thing that sometimes helps people. Notice how I'm writing everything down here? Look how everything lines up. All the x's line up. All the x squareds line up. All the numbers line up. So keeping everything vertically aligned kind of lets you know, well, where does this belong here, or does it belong somewhere else? Am I adding the right two things, subtracting the right two things? Everything should be lined up with the same exponent. All the x squareds, all the x's, and all the numbers. Okay, move this along. So, lead term, x. So x times what is x squared? X. And where does that go? Here? Right. Alright, yeah, so here's the other x, so it goes right above. Same exponent, same type of variable, all together. Distribute x squared minus x, right? And then which side? Minus, plus, 0, and 12. X, again, all lined up. times what is negative x squared? Oh, sorry, negative 12x. And we get minus 12. Negative 12x plus 12. Change both signs. Positive plus negative. And you see 0 and 0. Just for argument's sake, just a reminder, what if this came out to be like 2? And then we just say, okay, plus 2 over x minus 1. So whatever the remainder is, goes on top. Whatever dividing by, that goes on the bottom. Same as it did with just numbers only. You will have some in your homework that has this. Notice how I do it, put a plus. Okay, so those are the nice quadratics that are easy to check. What about something like this that, yeah, this is the third power. So all the x's and all that stuff doesn't work anymore. All right, watch me do this one. Watch me set this up. Now what did I have to do on this? We have a to the third minus 64. It's here, but whenever you're missing some sort of exponent, like I go from a to the third just to a number, you gotta have the missing exponents counting down inside. So I'm missing x squared, a squared and an a. I have to put plus 0 a squared and plus 0 a. One of the small but very important details. Missing any descending exponents, you got to put in a 0. So let's be careful. A times what is a to the third? A squared. I'm going to write it right above this a squared. A squared times a, and a squared times negative 4. A squared. Again, look, all a squareds are lining up. Switch both sides. Negative, positive. Negative. 0 plus 4. 4. A squared. Down to 0 a. And repeat. We have a going into 4a squared. A times what is 4a squared? 4a. Positive 4a. Multiply. 4a squared. 4a times negative 4 is negative 16a. Switch the signs. Minus plus 16a. Bring down. 64. One more time. So still stuck on this lead term, right? Focus on the first term only. A times what is 16a? 16. 16 times a, 16a. 16 times negative 4 is 64. Change those signs. Add that, and you got your 0. And in the big picture, what does this all mean? A to the third minus 64 equals a minus 4 times our answer. There we go. That's what this means. Now we're going to investigate this a little bit more down the road, But if you're savvy, you might catch this, that this is a to the third minus 4 to the third. Right? This is a difference of cubes. There's actually a pattern to this answer. You notice minus 4, what do we have here? Minus 4, then a plus 4, and a plus 16. So there's a pattern to the difference of cubes. And we'll be looking closer at this chapter for sure. So similar to the difference of squares where we said if we had x squared minus 4, we knew it was x plus 2, x minus 2. Because that's x squared minus 2 squared. It's the same idea but with cubes. The pattern is a little bit longer, but it still works the same. So difference of cubes. Alright, so let's have you guys practice this. Very similar. Just with us. You guys try it on your own, see how it goes. First of all, the setup. What goes inside here? What is it? What is it? Plus
0
yep.
b squared
Plus
0 b
plus
27.
give it a shot. Check as you go with someone. If you feel like you're getting lost, just check, glance over. I'd rather have you check, correct it, and then continue on as opposed to make one mistake in the beginning and miss everything afterwards. And a chain reaction when one little negative is wrong, it just makes the whole problem go bad.